We're going to do another little test with our fiber optic solar batteries. Let's get a good them under the lamp there. Okay, there we go. I want to get them close as possible. Okay, so that's good enough. And we have this light here. Now this light runs on 12 volts and about 2 amps to really get it to shine, and it shines super bright. Okay, but let's connect our leads. Let's get this lead and we'll show you how bright this light gets. There, barely comes on, but it's on. That means we got our 12 volts, but we have no amps in there. Okay, so now let's look. Let's see, we get another test here, and here we go. Let's put that into equation. Okay, this is hooked to a battery pack here, which means those batteries have amps in it. And when we push this button here, we're going to compare it to that. Now watch. See the difference? That is almost as bright as it's supposed to be. Okay, so let's put that away. Now we understand where it's supposed to be, but we do got light off of it. And let's do something. Let's take this off of here. And that was 2 of them. Okay, and let's see. It's still there. Okay, let's see if it lights up. Look at that. It still lights up. See how dimmer it is? Just from using one. And the light is not going in. The light is not even going directly into the fiber optic. So that means that this one should get brighter. Let's see if we can get this back touching. Get out the way. Okay, touch. There it is, lit up. Okay, let's get this. Look at that. See? So let's do that. Look at that. See? This is a fantastic test of this because it's telling me everything I need to know. Look at that. I can brighten it. I can dim it. And like I say, we know it puts out 12 volts, but it has no amps in it. And we need 2 full amps to run these. So the fact that it comes on means I know exactly what to do. We're going to get our amps on the battery here. That's going to lay on the side. And probably use capacitors or batteries. We don't know yet. Let's keep experimenting. All right. Okay. I got those. What is that? Okay. I got those leads connected to a capacitor on this board. And I'm using my fiber optic solar batteries to charge it. What I needed to find out, see if I can get a good picture of it. Can I charge that capacitor and run that LED light at the same time. Now, if you could see, I got 1 volt, or more than 1 volt, more than half a volt, more, 1.83 volts. That's what we'll say it that way. Okay, now here's the thing. Let's take this off of here. Let's see if we can. There we go. See how that goes up? It's going up really fast. Not super fast, but just really fast. Okay. But as soon as we touch it, see if we can get that touched. See that light come on? And it drops right back down. Let's go back. See? 3 volts, which will, like I said, I can tap it. See how am I tapping it? And the light's flashing. That's what it's going to do in the circuit that we're building. We just want to take a little bit of energy off of it at a time and then go to the next capacitor. So, but the simple fact is that light will stay on constantly. That voltage here will stay constantly. And the capacitor will stay full constantly as long as that thing receives light. So, we know for a fact, if we do that enough of those capacitors, then I'm going to say a battery will get enough charge to run the LED lights to keep those things over there supplied with energy to give back what they're supposed to give, which means that each one of these batteries here puts out 12 volts just from the light, and that's overpowering that. Even though this is like a dim little light, it's very dim. That's because those solar cells are not pushing amperage. Okay, so it's just pushing voltage basically. I mean, the milliamps is coming out of here. It's got to be crazy low, but that's okay. Again, it's not about how much amperage you got out of there. It's what you do with what you have. And I'm going to talk about that circuit a little bit later. Thanks. Okay, I wanted to disconnect let's see if we can get a reading in there. Okay, I just want to disconnect that, see if we can get a reading. It's kind of dark here. Come on. There we go. You see where it says 25? Let's do this. Come on. Can we focus in here now? Come on. There we go. See some light on here. Okay. These circuits, I just wanted to coming straight off of here. Here's that board that I was taking off that circuit. The rest of the board is damaged, and but it's a piece of garbage. I just wanted to save the capacitor there, and I got the leads coming off of here, positive hooked to negative hooked to my meter here. And now if I can just get some light in here for my meter. Okay. Wow, That is strange. Let's see if we can get a reflection off of there. See, I moved it, and now, okay. See where it says 25? There we go. We can see it clear now. Okay. 25 volts. Okay. But push through this and that LED, we was only getting one, basically the same thing as a battery would put out, a little bit more maybe. So that means that I had to overpower these into the unit. Okay, so you got your positive lead there, and you got your negative. No, that's the positive, and this is the negative. And it's coming directly out here, and it looks like a lot of voltage, but it has no amps. It has milliamps. So what happened is that when you run it through those circuits, your net is basically doing nothing. But I wanted to see how fast it was going to charge up, and it charged up really fast just from the volts. So this is our notes. Even though I got that, this basically is 1.5 volt is what I'm going to estimate that coming off of there is.